right. Hey, everyone. We're outside today, and we are in grade 6. This is lesson 11. Lesson 11, part 1, has 2 kids walking. And so we are going to actually model that out for you. And I have my phone here to show you the time. I don't know if you can see that because it's so bright out right now. But I'm going to say on your marks, get set, go. And then we're going to watch them walk at 2 different speeds. So here they go. On the marks, get set, go. So you might be able to see the time there, and you can also see them walking. One's walking faster, getting further and further away. One's walking slower, getting further away, but falling further and further behind. They're doing a great job. That's exactly what we want to notice from the problem in our book. So we're going to come back to the problem in our book in just a second. Okay, we're back inside now, and let's talk about what our book is having us look at, and I invite you to do the same thing that we just did. So we're on, like I said, Unit 5, Lesson 11. We're on page 257. Now, first of all, I would very much encourage you to do exactly what we just did, partly because it's fun. Get yourself out actually doing math, not just staring at me. You don't want to see more of my face on the screen or more whiteboard, right? You need to be out doing math. So grab your phone. In case those of you who know me are saying, well, I think Miss Cooper got a new phone. No, I just got a new case, because if you remember, my case was kind of junked out. So I got a new phone case, not a new phone. But open up to the stopwatch feature and actually do exactly what we just did. Find a friend who's in your family, someone in your family. Remember, you're social distancing. So brother, sister, aunt, uncle, grandma, grandpa, mom, dad, stepmom, stepdad, who's ever at your house, and say, hey, we need to do some math. And likely they'll say, okay, I'll do it with you, because doing math is a lot more fun than just watching someone else do math. So go do exactly what we did. Now, how far the distance you measured might be a little hard. You didn't see us actually measuring it, but you could. You actually could. You could go and grab a tape measure, one that people use for construction. If you have one of those around your house, works perfectly. If not, you literally could lay down. I'm 5'6", so I could lay down, and that's 5.5 feet, and mark where I laid down, and then lay down again. That would be a total of 11 feet. Lay down again, there's another 5.5 feet. So you could figure out how tall you are and actually lay down and do body measurements or something if you wanted to get some exercise and have some fun. So here's what we had going on. Student 1, every second that went by, they walked 3 feet. So after the first second, they'd walked 3 feet. After the second second, they'd walked 6 feet. After the third second, they'd walked 9 feet. Fourth second, 15 feet. Fifth second, 15 feet. So after the time had gone by 5 seconds, they walked 15 feet. Now let's see, what about student 2? Student 2, the time is the same. We're still timing seconds, and we were still using the same counting down on my phone. So after the first second, student 2 walked 5 feet. So in the first second, student 1 walked 3 feet. Student 2 walked 5 feet. After 2 seconds, student 2 had walked 10 feet. Now look at this. After 3 seconds, student 2 had gone 15 feet. In the same amount of time, 3 seconds, in the same amount of time, student 1 had only gone 9 feet. And you saw that in our video. You saw one of my sons walking quite a bit faster than the other one. So after 3 seconds, one of them was out in the lead, and one of them was further behind. Now, that's what this number line, these 2 double number lines, are showing us. They're showing us the time, and they're showing us how far each student had walked on that amount of time, after that given amount of time. Now, don't let the things that look like sort of semicircles, don't let that confuse you. All that means is that here's the time going by. They both started at 0. The person was walking, had walked 0 feet, and there was 0 seconds. In the time it took to go from 0 to 1 second, that's what that thing means. Just during that amount of time, from 0 to 1, the person walked from 0 feet to 3 feet. That's what those signs mean. Don't let those trick you. They're just showing you that time is going by, and in this case, distance is going by. Now, so what they want us to do then, they're going to give us some variables. They're going to tell us the time that goes by. They're going to call that t. So they're going to say t equals the time in seconds. We're counting it in seconds. They also want us to take a look at d, the distance, how far we've gone. Now, this is distance for student 1 and distance for student 2. So I'm going to call this d with a tiny little 1 down below equals distance in feet. And then I'm going to do the same thing, but with my purple, because student 2 also has a distance d, and I'm going to put a little 2. Those are called subscripts. So instead of putting it up like exponents, superscripts, these are subscripts. They go down below. So d2, the distance of student 2, is also distance in feet. Okay, now if we were in class together, this is the time I would want you to write down some notes to help yourself remember. And remember, when we're talking about notes, you always hear me say we need words and pictures and numbers. So we're talking about an independent and dependent variables. You may have talked about them a little bit in science. If you did, great, this isn't new. If you haven't, well, this is the introduction and you'll get more about it in science probably. So independent variables. That's on a variable, some number that we don't know, that indicates or shows a variable whose value influences another variable. So it has the influencing factor. It has the changing factor. It's shown on the x-axis. So I wrote shown on the x-axis, and I drew a little picture to show the x-axis with my arrow pointing there. And it's also shown on the left column in a table. So I drew a table and showed you the left column. So please pause the video for a second and write this information down before you go on to the dependent variable. Then we'll actually add some numbers in too. Okay, so the other choice is a dependent variable. So it's an independent or a dependent, and we'll talk more about that in just a minute. A dependent variable, please pause this and write this down. It's a variable whose value, that means like the number it's worth, depends on other variables. We show it on the y-axis, so you might want to draw a picture again, just like I did to show the y, and we show it on the right-hand column in a table. Now you might be saying, okay, but what does this have to do with those kids walking? Well, let me erase here for a second and we'll talk about it. Okay, so we're going to put the information into a table, and I think the variable conversation will make a lot more sense. So we're talking about independent and dependent variables. What do you notice about these two tables? I'm looking on page 258. What do you notice that's the same or different about them? Well, hopefully you notice that the time in seconds is the same. It's on the left-hand side. That automatically tells us that's the independent variable, because as the time ticks by, how far they go is the thing that changes. The time just keeps ticking on. It's how far they've walked, how far away they've walked, that is the bigger change. That's the dependent variable. It changes as these seconds go by. And I've written the seconds right here in black. Now you can see that t, there's the independent variable, t, the time in seconds, and t, the time in seconds. And you can see d1, the distance student 1 walked in feet, and the distance student 2 walked in feet. Now you're going to have to change your page back and forth, which is a little cumbersome, but you can do it. So you're going to have to look back on the previous page to get the data. So student 1 is walking 3 feet every second. So 3 feet, then 6, then 9, etc. So let's put that in for student 1. 0, in 0 seconds, they haven't walked any. It's 0. But after 1 second, they've walked 3. 2 seconds, they've walked 6. 3, 9, then 12, 15. There's the dependent variable changing. Now, here's student 2. the distance they walked in feet. Again, at 0 seconds, they hadn't walked any distance at all. But after the first second, they've walked 5 feet. They're walking faster. They're covering more ground. So they've covered 5 feet in the same time it took this person to cover 3 feet. After 2 seconds, they've gone 10 feet. After 3 seconds, they've gone 15 feet. So in 3 seconds, they went 15 feet, whereas student 1, in 5 seconds, it took them 5 seconds, it took them 2 seconds longer to go 15 feet. So 5, 10, 15, 20, 25. We can keep continuing, assuming that that student keeps walking, we can continue the table on and on. In fact, we could put more rows down on the bottom if we wanted to. Let's go on to number 3, the question on page 258. Question number 3, we need to write an equation for relating the time and the distance for each student. So we have student 2 is in purple, and student 1 is in red. Now we need to relate the time and the distance. What is the relationship here between the time and the distance? What's going on in the middle here that tells us what the relationship is? Well, hopefully you're noticing 1 something 3, 2 times something equals 6, 3 times something equals 9. And hopefully you're noticing it's the same something. It is multiplied by 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. So t times 3 equals distance 1. So 3 times the time equals distance 1. Or you could also write that distance 1 equals 1/3. 1/3 of the distance equals the time. You could say the time equals 1/3 of distance 1. You could write them either way. What about student 2? What's the relationship that's going on in there? Hopefully you're noticing that it's multiplied by 5. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. So instead of being 3 times t to get to d, we have 5 times t to get to d. So student 2 is 5t. 5 times the time gets us to distance 2. Or you could switch it around and say the time is 1/5 of distance 2. 1/5 times the distance. Now our book wants you to go ahead and graph that information onto the graph on page 259. We've done quite a lot of graphing, so please make sure that you're graphing. You're looking at the labels here. This is feet walked and seconds elapsed. This is feet walked and seconds elapsed. So that should be a review for you. We'll come back tomorrow with part 2 in lesson 11. Good luck.